Binomial expansion. This is our first video for this topic. And binomial expansion is a dense topic. Dense, D-E-N-S-E. When something is dense, that something occupies a small space, but that tiny space or small space contains a lot of content. And that is how binomial expansion is. So we will not unload all ideas that is concerned with binomial expansion. We may have to devote something like 7 or 8 videos just for this topic. But in this video, we will pay attention only to the basics of binomial expansion. So let us review. Let us review our understanding of binomial expansion. Well, our understanding of binomial expansion has something to do with getting the product, and for some of you who have the fortitude to memorize the formula, that is what you remember about binomial expansions. The formula or the special product. Let us get the special product of this, the square of x plus y, just in case you don't recall or cannot recall the special product for this. Well, what you can do is you can just multiply x plus y times x plus y. Multiply it term by term, combine similar terms, and it is equal to x squared plus 2xy plus y squared. How about the cube of x plus y? Now, I think for many students, this is a challenge. Well, this is what you can do. You can write this as the square of x plus y times x plus y. And you already know the product of the square of x plus y. So you multiply this trinomial to the binomial, multiply it term by term, combine similar terms, and this is what you will get. How about when it's the quantity x plus y raised to 4? You know what? Even I cannot recall the special product for this. What I would do is I will just decompose this into two binomial, the square of x plus y times the square of x plus y, and then I will multiply these trinomials term by term, combine similar terms, and apply the laws of exponents, and this is what I've got. Let us look into the patterns and symmetry that arise from expanding a binomial. The one pattern that we can see here is each of our terms is of degree 2. How can you tell the degree of a term? Well, the exponent of the variables. So this one is a degree 2 term. Here, what you do is you add the exponents of your variables. So this is going to be 1 plus 1. Again, degree 2. It's the same with y squared. So that is one pattern that you can see from the expansion of a binomial. You can see that pattern here. X plus y raised to 3. So each of the terms must be a degree 3 term. Look at this, x cubed. You add the exponents of x and y, it's 2 plus 1, it's 3. The same with exponents of x and y here. 1 plus 2, again, that's 3. And this one is a degree 3 term. It's the same with the fourth power of x plus y. Well, one thing for sure is each term is going to be a degree 4 term. Degree 4, 3 plus 1, that's 4, 2 plus 2. And this one is a degree 4 term. Okay, what else? One pattern that stands out is, if you were to write this in standard form, look at the degree of x. Okay, so this one is a degree 3 polynomial. Look at the degree of x. It's descending. X cubed, x squared, x to the 1, and actually here you have x. It's x to the 0. Any non-zero real number raised to 0 is equal to 1. So you have x to the 0 here. Again, it's descending exponents. 3, 2, 1, x to the 0. On the other hand, the other term y, will show an ascending exponent. That's the pattern that I see. So you have here a y raised to 0. So 0, y raised to 0, y raised to 1, to 2, and to 3. You can apply that same pattern here. Look at the degree of x. 4, 3, 2, 1, 0. How about y? 0, 1, 2, 3, and 4. How about x plus y raised to the 5th power? Having said those patterns, well, you are sure now that each of the terms is going to be a degree 5 term. You can write the terms one by one. You can ignore the coefficients for the moment. You can just write the literal coefficients of each term. So it's going to be x to the 5th, x to the 4th, x cubed, x squared, x to the 1, and then x to the 0. And at the same time, y to the 0, y to the 1, y to the 2, 3, 4, and 5. So that's the pattern. Now, how about symmetry? You know, when you say symmetry, it's like one part is the mirror image of the other part. And there is some symmetry here. We will draw a vertical line at the middle and look at the symmetry here. Degree 2, coefficients 1 and 1. How about with the cube? X plus y cube, okay? Look at this, 3, 3. Look at that. Look at the coefficients, 3, 3. With this one, okay, 1, 1, 4, 4. And then you have 6 in the middle. And this one, okay, look at that. It's like you can fold this strip of paper along this line and the coefficients will match each other. Okay, 1, 1, 5, 5, 10, 10. When students meet this, and they know that there is a special product again for this, a separate special product, many students would just kind of give up. Hey, this is a lot of formula. And I think many students have a resistance, or they are averse to memorizing formula. But this is what you can do. Just in case you have an aversion for formula, you can write it as x plus the negative of y. And you will apply the special product for x plus y, but you will not remove the negative sign. You will just stick the negative sign to y. Okay, so look at what happens. Applying our binomial expansion for x plus y, this is it. But you stick the negative sign to y. And then after that, you will simplify it. So you can now simplify this. This is going to be 2x times negative. So that's going to be negative. That one. And a negative raised to 2 is always going to be positive. So that's it. That is your special product for the square of x minus y. It's the same for the cube of x minus y. You can write x minus y as x plus the negative of y. And then apply your special product to x plus y. Okay, don't remove the negative sign to y. Just keep it there. After you have expanded the binomial for cube, that's when you apply the laws of exponents. So this is positive times negative, so it's going to be negative. Positive, but this one is always positive because it's square. So it's just positive. And this one is negative raised to cube. That's odd. A negative number raised to an odd integer is going to be negative. That's why it's minus there. So that is one guide, one help, I hope, that you can remember when expanding binomials such as this.